All right, good morning and welcome. Today we are going to talk about how do we convert between rectangular coordinates and polar coordinates. So yesterday we did talk about what polar coordinates are, how to find them. If you weren't here yesterday, you'll probably need to start by watching that video. But second thing I want to point out, make sure you are in Delta Math to watch this video so you get points for it. If you somehow are on YouTube or you're watching it through Canvas, stop, go to Delta Math and log in and watch it through that assignment so you get the points. So rectangular coordinates, you guys have dealt with these for a long time. You know it's an X and a Y coordinate. After yesterday, hopefully you remember, for polar coordinates, it's still two variables, but it's r and theta. R stands for the radius, or how far we are from the center of the circle. Theta stands for what the angle is. Keep in mind, that's kind of using that same framework as our unit circle with 0 degrees or 0 radians being to the right. Okay, so you are asked here to convert each polar coordinate into a rectangular coordinate. Now, when we are converting, so this originally 6 pi over 6, that location, r theta, that has an xy coordinate that matches up to that same spot. Okay, so to convert between them, if we have r and theta, we can use this to figure out what it is. Okay, so x we know is our cosine, y is our sine. If we take whatever that radius is times the cosine of whatever our angle is, or whatever the radius is times the sine of our angle, we will find that x and y value. Okay, so for this first one, so our radius is 6, our theta is pi over 6, so x, to find our x value, we will take 6 times the cosine, right? X is always cosine of pi over 6. To find our y value, we are going to take 6 times the sine of pi over 6. If you're rusty, pull out your unit circle, take a look at that. So cosine of pi over 6, at pi over 6, the cosine, the x value is root 3 over 2. So 6, I'm going to rewrite it 6 over 1 times root 3 over 2. We multiply that, we're going to get 6 root 3 over 2, which reduces then x we know will be 3 root 3. 2 goes into 6 3 times. Okay, we'll do the same thing except for y, it'll be times the sine. So the sine of pi over 6 is actually just 1/2. What is 6 times 1/2? We get 6 over 2, which, as you guys all know, reduces to 3. Okay, so the final step, I'm asking you to write this in rectangular coordinates. Right now I have the two values, the x and the y. To write it in rectangular coordinates, I need to write it as an ordered pair here, 3 root 3 and 3. We're going to leave it in that square root form. That is our final answer right there. Okay, so that's my answer to number 1. All right. Question 2, 5, 0. So a radius of 5 and a theta of 0. So once again, if it helps you, label them. So for x, we know it's 5 times the cosine of 0. For the y, we know it is 5 times the sine of 0. Now, the cosine of 0 is 1, so 5 times 1, x just is going to equal 5. For the sine of 0 is 0, so it'll be 5 times 0. That means y equals 0. Now you might have noticed 5, 0, it is the same thing. Why is that? Well, if we think about it, the point 5, 0, if it's on that 0 for theta, it's going to be, it's going to be off to the right, somewhere over here, 5 out. That is not up or down at all, so it's still a value of 0, and it's 5 away from the center, so it's going to be the same point in either form. Okay, it will not always be that way, but in this case, 5, 0 is the same as 5, 0. All right, as we go, this time, the radius is maybe a little more complicated. So we look here, it's 4 root 2 times the cosine of 7 pi over 4. You're not going to need on any of these, and then for this one, it's 4 root 2 times the sine of 7 pi over 4. You shouldn't need your calculator for any of these as long as you have your unit circle or you remember the values of both sine and cosine. So 7 pi over 4, the cosine is going to be root 2 over 2. So I'm going to rewrite this 4 root 2 over 1 times root 2 over 2. That's going to come out, so on the top here, 4 root 2 times root 2, that becomes root 2 times root 2 is 2, 4 times 2 is 8. So 8 over 2, which reduces to 4. And it'll be very similar for this for sine, except it's a negative. So if it's a negative, it will be negative 4. And that's our y value. So my answer then for negative 4, we're going to write it as an ordered pair. Make sure you put it as an ordered pair when you answer in delta. And we have one final question here. Same concept, right? So for our x, it's just 8 root 3 times the cosine of that 2 pi over 3. For the y, same thing. 8 root 3 times the sine of 2 pi over 3. X is always with cosine, y is always with sine. Okay, so we multiply this 8 root 3 over 1 if you want times negative 1/2. This one will be 8 root 3 over 1 times root 3 over 2. Okay, so for the first one times negative 1/2, that means here we'll get negative 8 root 3 over 2, which comes out to negative 4 root 3. For the second one, for the y value, root 3 times root 3 is 3. 3 times 8 is 24, so you'll get 24 over 2. But at that point now we divide it and we get 12. So you'll see our new answer, negative 4 root 3, comma 12. Okay, so if we are given it in polar coordinates, that is how we get to rectangular coordinates. To go the other way, okay, we will simply, if we think about it, if we're going the other way, if I have some point graphed, I know it's over here. If I take my x, here let me switch to red, my x and my y and I square them, I will figure out that distance because that makes a right angle. So you see how x and y to find r. So r squared equals x squared plus y squared. Now keep in mind here you're going to still need to square root that. And to figure out what the angle is, TOA, right? So that's our O and our A. So we take our tangent of theta equals y over x. So we're going to do our inverse tan to figure out what that value of theta is. Okay? So for this first one, this is my x, this is my y, and I am trying to get this into into polar coordinates. So I'm going to start off. Here by finding my r. So r squared equals, and it's negative 1 squared plus whatever negative root 3 squared is. Okay, and at this point then I know r squared will equal 1 plus 3. If you're not sure about this, negative 1 squared, negative times negative is positive. Same thing here, negative times negative is positive. Root 3 times root 3 is 3. 1 plus 3 is 4, so r squared equals 4. And at this point, I'm going to take my square root. The square root is 2. Now, I know you could do it as 2 or negative 2. However, in order for us to use this formula for theta, you're going to need to do the positive version. Okay, so for this situation, to make it work out, it's going to be 2. If you think about it real quick, this is a little sketch. We know that this negative 1, negative root 3 is somewhere down here in quadrant 3. Okay, so that might not be the exact location, but it's somewhere over here in quadrant 3. So that gives me my r value. That's the distance it'll be. Now I need my theta value. So we know it has to be between pi and 3 pi over 2 because it's in quadrant 3. So I go ahead and tangent of theta. Where is tangent of theta? Y over x. Now, first thing I want to point out, they're both negative, so we can cancel the negatives, and it reduces to tangent of theta equals root 3. So we have to ask ourselves, in quadrant 3, and once again, why do I know it's quadrant 3? Well, x and y were both negative, that's left and down. In quadrant 3, we have to ask ourselves, at what location is tangent root 3? So that will occur at 4 pi over 3. Okay, if you're struggling with that, just go and check where y divided by x gives you root 3, and that is at 4 pi over 3. So now I'll write my ordered pair here, 2, 4 pi over 3, and I am done. That is my answer. So second one, once again, start it off the same way. We always start it by finding our r. So r squared will equal x squared plus y squared. In this case, they are the same, so it'll be 25 plus 25. And those add together, r squared equals 50. That means r equals the square root of 50. Now, if you leave that like that, it will probably count it wrong on delta. That is not how it wants it, okay? Instead, we need to break this apart. So 5 times 10, 5 can't break down. 10 is 5 times 2. We have a pair of 5s. That can be rewritten as 5 root 2. That is our value of r after we simplify it. Okay, so now we need to also find our theta value. So once again, let's think about this. Which quadrant? So 5, 5, that's somewhere in quadrant 1. So we are in quadrant 1. We are wondering where is the tangent of theta? 5 divided by 5. Well, what is 5 divided by 5? 5 divided by 5 is just 1. So where is the tangent of theta equal to 1? And that occurs at pi over 4. So to write this as polar coordinates, we would put 5 root 2 and then pi over 4 for your theta value. And we are done. All right, 2 more problems. So on number 7, if you want to pause the video and try one of these on your own, that's fine. Number 7, r squared equals negative 6 squared plus 2 root 3 squared. This one maybe gives you a little trouble on that part, but so negative 6 squared is 36 plus, if you're struggling, remember 2 root 3 times 2 root 3 is what that's saying. 2 times 2 would give us 4. Root 3 times root 3 will give us 3. 4 times 3 is 12, okay? At this point, we're going to combine them. 36 and 12 gives us 48. And then we take our square root. Square root of 48, so close. 49 is a perfect square, but it's not. So we need to break it down. So 16 times 3. 16 then can be 4 times 4 times 3. Some of you will notice there's a pair there you can circle. If you don't notice that, keep going. 2 times 2 times 2 times 2 times 3. A pair of 2's, another pair of 2's. 2 times 2 is 4. R is going to equal 4 root 3. As you can see, you could have just circled this pair of 4's and brought that up front, and then you would have 4 root 3 as well. Okay, now, once again, we care about which quadrant this is in. So I don't have to really know the location, I just need to know the quadrant. So it's negative for x and positive for y. That has to be up here in quadrant 2. So y divided by x, where is tangent? If you forget that, remember tangent we know is sine over cosine, so that's y over x. Okay, so 2 root 3 over negative 6. We can reduce that. So the 2 goes into 6 3 times. So it will be negative root 3 that we're looking for over 3. Okay, and where does that occur? Well, we know it has to be in quadrant 2, and it will occur at 5 pi over 6. Okay, so 4 root 3, 5 pi over 6. All right, one more. All right, our last one, and I'll try to keep it quick because I know this video is getting longer than I meant it to. So once again, r squared equals x squared plus y squared. Each of those will just become 2. 2 plus 2. This one is really nice because r squared equals 4. That is a perfect square, so r equals 2. Okay, at this point we care about the quadrant, right? Right and down is somewhere in quadrant 4. Tangent of theta, negative root 2 over root 2. That's going to reduce to where is the tangent of theta equal to negative 1. That occurs at 7 pi over 4. And the only step left then is write your ordered pair. So go ahead, finish this delta. There's a few practice going each way. If you forget, always go ahead and look right up here. You can convert using these formulas. Okay. If you have questions, ask me tomorrow, but give this a go. Let's get that done, and I'll see you guys on Wednesday. Hope you guys have a great day. Bye.